Again, this question says write each expression as a single logarithm. That means the same thing as simplify. So if we look back at our formulas from the last question, 1, 2, and 3 here, we're wanting to write things as the left-hand side. The left-hand side is where we have a single logarithm. The right-hand side is considered the expanded side. So in A here, we want to write this as a single logarithm. Now we see log plus log, and if most people, when they see this, the first thing they're going to go to is rule number 1. I see adding, so I want to multiply. But the difference between what we have here in A and what the formula says log plus log. And what we have is log plus 3 log. So in fact, we won't be able to use the first formula because we have a 3 out in front, and it doesn't match up. That formula doesn't have that 3 in there. I got to get rid of it so you don't get confused. The formula only works, number 1, if it's a log plus a log. So we have a problem because we have a 3 out in front. What can we do with that 3 out in front? Well, we can use our power law. If you have a number out in front, it can go inside the logarithm as an exponent. So as a first step, I'm going to take this question and just do that. I'm going to move that 3 in as an exponent. And now it matches up with our first formula. It's a log plus a log. So now I can combine those. Adding is multiplying. And it becomes log xy cubed. In B, again, we have some numbers out in front. So we won't be able to add or subtract until those numbers are out, because both the adding and the subtracting one, number 1 and 2, they only work when it's a log plus a log or a log minus a log. And so the first thing I'm going to do is I'm going to put those numbers in as exponents. So that 2 will go in as exponent, become y squared, and the 4 will go in an exponent as z to the 4. And now I could combine the first 2 together because I have a log plus a log. I could combine the last ones together because I have a log minus a log. And in fact, what I'm going to get you to do when you have both formula 1 and formula 2, when you have the product rule and the quotient rule, we can actually do them together. And so when I have this situation, I'm going to go right to my final answer. And whatever is adding is going to be your product rule, and that will appear in your numerator. So x plus y squared will become x times y squared. And whatever is subtracting, in this case the z to the 4, that will become in your denominator for the quotient rule. Which can be really handy, because if I add an example in here, b.5, and I said, well, what is log a minus log b minus log c squared plus log d cubed? I've already put those powers inside. And now I just have a bunch of logs adding and subtracting. I want you to be able to go directly to the answer and say, whatever is adding, in this case, can you see the log a is positive and the log d cubed is positive? That will get combined as your product rule, and that will appear in your numerator, ad cubed. And whatever is subtracted, in this case the log b and the log c cubed, those will get combined in your denominator. And you'll be able to combine any sort of logs all together at once, which is really nice and really simple. And now when we get to part C, we have log base 2 of 6 minus 3, and we run into a problem. Because how do we combine these to a single logarithm when one is a logarithm and one is a number? And so what we have to do here is we say, well, I'm able to subtract and combine logarithms if they're the same base. So if there was a way that I could change this 3, I'll do it in green, to log base 2 of something, then I'll be able to continue from there and work with my log laws. But this is the hard step. What do I put in that space? 3 is equal to log base 2 of what? So basically off to the side, I could say to myself, okay, this is what I want to figure out. Log base 2 of something equals 8. No, you never saw that. Equals 3. I wonder what the answer might be. Anyways, so log base 2 of something is equal to 3. How do we figure that out? Well, you might use your definition of a logarithm. Because when you're solving for logarithms, sometimes it's easier to think about if we use our definition. When I have a log like this, the 2 is my base. The 3 is my exponent, and the space is whatever it's equal to. And in this case, is it easy to see that the answer is 8? Right? Despite the fact that I gave it away 10 seconds ago. And so here, log 2 of 8 is equal to 3. And remember that when we're dealing with logarithms, we're solving for exponents, and sometimes we're saying log 2 to what power of 3 would be equal to what? This has to be 8. And now we have a log base 2 minus another log base 2. Subtracting is dividing. And so you could leave that as 6/8, or you could simplify it to 3/4. Either one would be fine. Cool. All right, so ones to do for practice: 5, 8, 11, and 18. And if you want to think about this one a little bit further, y is, what did we have? Log 2 of 6 minus 3. Y is log 2 of 6 minus 3 equal to log 2 of 3 minus 2. That's, if you want to fiddle around with logarithms, type those into your calculator, see if they're equal, and if they are, why are they equal? Okay, questions 5, 8, 11, and 18.